Okay, in ionic bonding is different from covalent bonding. So far, we've been talking about sharing electrons. Okay, in ionic bonding, they borrow. You could say that. Okay, so let's look at something really simple to start with. So here's sodium, and the orbital notation for sodium is located right here on the periodic table. So we're going to fill up the first primary energy level and the second primary energy level, and we're just going to put one electron in the third primary energy level, and that electron is in the S sublevel because this is the S sublevel region. Okay? So here's the first energy level, 1. We only have one sublevel, S, and there's 2 electrons there. And then in the second primary energy level, starting with lithium on the periodic table and beryllium, okay, there's a 2s sublevel, and we have 2 electrons, which correspond to the position of lithium and beryllium here. Then we're going to be over here in the p sublevel region. So this is 2p. We're going to put electrons in now, and there are 3 orbitals in 2p. And we put 1, 2, 3, and then go back and pair them up. And so we have 3s now. Okay? And there's 1 electron in 3s because sodium is the first element in the third row of the periodic table. So it has 1 electron in the third primary energy level. All right. What I want to do is to find a place. Now listen, here's what wants to this is what want this. I would appreciate it if you would be patient and wait for him to return. Sodium's electron then can leave this orbital and join up there. What that does is it gives fluorine a full energy level. Its primary energy level, or its valence level rather, its highest energy level is now full of electrons, which is what it wants. And sodium has given up an electron in its highest energy level, leaving it with a full outer energy level, stabilizing the whole system. But now this means that sodium has 1 less electron. Sodium had 11 protons. There's sodium there. There's the 11 protons because that's the atomic number. It had 11 electrons, but now it doesn't. It has 10 electrons. Protons, remember, are positive. Okay, protons are positive. Electrons are negative. Okay? So if I have 1 more proton than electrons, this element here is now positive. It's not an atom anymore. It's now an ion. It's not an atom anymore. It's an ion. Since fluorine has gained an electron, it has 1 more electron than protons. Fluorine has gained an electron here. It has 1 more electron than protons. Electrons are negative, protons are positive. That makes fluorine negative. Every time you gain an extra electron, you become 1 more negative than you were before. Every time you lose an electron, you become 1 more positive than you were before. So these are not atoms anymore. These are now ions. Chlorine is located right here. Okay? I hadn't finished yet. I stopped there for a reason. What I've done so far, well, let me show you let me make sure we're clear about lithium first, I guess, okay? Lithium's right here.
1s, 2s, 2p.
There's no 2p. 1s we fill up because helium belongs over here, and so we got 2 electrons there, but there's only 1 electron in 2s because lithium is the first element there.
Why do you go from 1 to 2? The second? The 1?
Because we go to the second row.
And if you go to the third row, you put 3?
3. That's what we're going to do with chlorine in a second. See, chlorine's on the third row.
But what about the 2? Why do you go from p? That's just the round.
Because this is the 2p section here. Chlorine is on the next row, so I'm going to fill that up completely. You fill them up, 1s, 2s, 2p.
You go till you reach it.
Yeah.
Hey, I didn't even do that, and I did it right. Oh, good job.
And then 3s is right here where sodium and magnesium are. I've got 2 electrons there. 1, 2. And then I got to have 1, 2, 3, 4, 5 electrons in 3p.
Where's Carmelo?
Taking a test.
I know you did.
Okay. So, this 1 electron right here, Tubby, Logan, this 1 electron right here leaves lithium. That leaves lithium with a full energy level because the first energy level only has 2 electrons. It leaves and it can go down here to chlorine. Now chlorine has a full outer energy level. Lithium has a full energy level, although we got rid of its valence level. Right, since lithium lost an electron, it has 1 more proton than electron, so it's positive. Since chlorine has gained an electron, it has 1 more electron than protons, so it's negative. Okay? That's right. That's how you get them. You were talking earlier about how they attract each other. Well, this is how that happens. If I have a positive particle and a negative particle, then they do attract each other. Okay? We're still in Unit 3. Okay? All right, let's try one more. This is going to be a little bit different. Write the orbital notation for magnesium and for fluorine and show how the electrons move to create ions. So the next assignment is to write the orbital notation for sodium and for sulfur and show how the electrons move to create ions. So here's the mechanism, the method for showing how magnesium and fluorine are going to combine ionically. You have a magnesium that has a 2+ charge because it's going to lose both its electrons and its outer energy level. That way it's going to have, what remains is a full energy level, 1 level down from its valence level. And those 2 electrons, the first electron goes to this fluorine. So there's 1 more fluorine added to, or 1 more electron added to fluorine. It has a 1 negative charge. But that second electron needs a second fluorine for it to go to. And so you have to move that second, you have to say, okay, do I have enough fluorines for the magnesium's electrons to go to? If not, you write more fluorines. If the converse were true, that I had 1 electron to give away, but something else needed 2 electrons, then I would need 2 magnesiums in order to fill up the spaces available and the non-metal here. So the metal gives up electrons, the non-metal gains electrons, And then we get to the Lewis dot formulas. The electrons leave here and go to the fluorine, and leave there and go to the fluorine. So you got 2 fluorines and 1 magnesium. So the homework then is do all the above for a combination of aluminum and sulfur. Aluminum and sulfur.